Okay, this is solving logarithmic equations. Oops. Here's the first page one more time. Okay, and then solving. For number one, what we want to do is rewrite this in exponential form, because that would be 2 to the third power equals x minus 4. 2 to the third is 8, and if I add 4 on both sides, I get 12. So x equals 12. Over here, actually we have to check these answers. The most important thing is that this cannot be negative. This is called your argument. This cannot be a negative. Now this one's pretty easy. If you take 12 and you put it up here, that's going to be log base 2 of 12 minus 4, which is 8. And that's fine. So that means our answer is valid and we can stick with it. Okay, now the second question. We have to divide by 4 first to isolate our logarithm, to get it by itself. So there we go. We've got the logarithm of 3x equals 2. And then I'm going to change this to a different notation, log base e of 3 of x equals 2. And then do the same thing I did over there. I'm going to write it in exponential form. So it'd be e to the second power equals 3x. Now I can take my calculator and I can type in e to the second power. But on this one, they actually just want you to leave it as a regular value, e to the second. So in this case, we're actually just going to divide both sides by 3. And so we get x equals e to the second divided by 3. Now, is that a valid answer? Well, as long as this part is not negative, then it is. So that's going to be the natural log of 3, this part right here alone, would be 3 times e to the second divided by 3. And the 3's will cancel and you're just going to get e to the second. Now e is approximately 2.71, so if you square that, you're still going to get a positive answer. So this part is okay. It's positive with the answer that we got. So that's okay. That's a valid answer. Okay. The next one, we're going to have to use our quotient rule. So if we put these together, okay, so putting these together with the quotient rule, we have log base 4 of x plus 3 over 5x minus 1 equals 3. And then we'll use our exponential form. So that would be 4, I'm going to move it over here, 4 to the third power equals x plus 3 over 5x minus 1. Now 4 to the third power, 4 times 4 is 16, times 4 again is 64. And then I can solve this by cross multiplying, so I'll multiply this way and then this way. So if you think of 64 as 64 over 1, and then you multiply 64 times 5, you get 320. X minus 64 equals, and then 1 times x plus 3 is just x plus 3. Subtracting 1 on both sides gives you 319x. Adding 64 on both sides gives you 67. Now, I'm just a little befuddled with this because I'm going to get a decimal here, but I'm hoping that's okay. 67 and 319 I don't believe have any 67. Okay, so 67 and doesn't divide evenly into 319, or vice versa, you can't reduce it. So we're dividing both sides by 319, so we get 67 3/19. And so that does not reduce. And so if we use that up here, that's a positive number. If we add 3 to it, that'll still be positive, so that's good. We multiply it by 5 and then subtract 1. So 67 times 5 divided by 319. And then if I subtract 1, yep, that's still going to be a positive number here. So this answer is perfectly fine here and here. Both of them are positive values. So that means it's a valid answer, and we can keep it. Number 4. Okay, number 4. Again, we can use our product rule. So we're going to take log of x times x minus 3 equals 1. When you don't have a base, we assume the base is 10. And then if I write this in exponential form, that would be 10 to the first equals x times x minus 3. And what I'm going to do is I'm going to write it as a second degree polynomial. So that means I'm going to distribute here x squared minus 3x. I'm going to minus 10 on both sides. And then therefore I have a 0 on one side. Once I do that, I can solve for x by factoring. This is factorable. It's x minus 5 times x plus 2. And so my two answers would be 5 and negative 2. However, if I use negative 2 and I put it back up here into this argument, that would make it negative. Now, it would also make a negative over here, but it doesn't matter. If either one of these turns into a negative value in the argument, the answer is not valid. So I'm going to invalidate my negative 2 as my answer and check 5. Is 5 going to work here? Yep, 5 is positive. Is 5 going to work here? Yep, 5 minus 3, positive 2, that's positive. So the only answer I can keep is x equals 5. And then the last example, I think it's the last one. No, we have one more. Is this one. It's pretty complicated, but we'll start with this one using our quotient rule. So that's the natural log of 7x minus 23 over x plus 1. Okay. And then, since both of these things are the same except for the arguments, I'm simply going to set the arguments equal to one another. It's just logical that they would be equal, having everything else being equal. I'm now going to cross multiply, so if I write this over 1, I get x minus 3 times x plus 1 equals 7x minus 23. And if I FOIL this out, I get x squared minus 2x minus 3. And then if I'm going to subtract 7x on both sides, which gives me minus 9x, and I'm going to add 23 on both sides, which gives me positive 20. Setting it equal to 0 and factoring gives me x minus 5 and x minus 4. So my two answers, my two potential answers, are x equals 5 and x equals 4. Now, are those valid answers? Well, we have to check every argument up here. Does the 3 work, or sorry, the 5? 5 minus 3 is 2, that's positive. 5 times 3 is 35, take away 23 from that, that's still positive. 5 plus 1 is 6, that's positive. So this one works in all cases, so we can keep our x equals 5. Does the 4 work here? Yes. Does the 4 work here? 28 minus 23? Yes. Does the 4 work here? 4 plus 1, 5? Yes. So it turns out that this one does have both answers. They both check out okay, giving us a positive value in our argument on each of the original arguments. Now, I've only got one more minute for this one, so I think I'm just going to have to show it to you. Here, this is my notes on this one. Basically, this one is putting in values that we used when we were doing our compound interest. I'm just going to zoom in on the top part here. This is my original setup right there. And then I started solving by actually dividing by 1,000. And then I got this, which gives me something I can simplify a little bit further. And when I get to here, what I'm going to do is use a logarithm. Log base 1.02 of 3.6 equals 4t. That's the hard step right here. And then once we have a log with two number values in the base and the argument, then I can use the change of base formula, which gets me a value. And then I just divide by 4. And there it is again.